always say make IT better for society. Every scientific invention has got its good and bad sides, but certainly we want to improve the usefulness of technology in society, and we work on all sorts of levels for that. We work in schools. The national curriculum for teaching IT is was put together by the BCS, for example. So we do a lot of work in schools, and if you want to know more, go to bcs.org. If you're not a BCS member and you'd like to join, then obviously we'd love to have you as a member. We celebrate the contribution that IT professionals make during these difficult times. And so if you look for the hashtag vital worker, you will see posts about acknowledgements, celebrations of IT workers who have been helping us through the pandemic. BCS Berkshire have tonight's event. We also have an event on the 13th of July, which will be a hybrid event. There'll be, so it's in person in Reading, but also accessible online. So this will be the first time we've done a hybrid event from BCS Berkshire, actually, and that will be on the Internet of Things as in Reading, the LoRaWAN applications in Berkshire. Somebody that's spoken to us, it'll be the third time he's spoken to us, Mark Stanley. Highly recommend him. That man can make lampposts talk to each other. It's very, very interesting stuff. And it's quite an eye-opener to know what's happening in Reading. Reading is actually at the forefront of what's happening in the country, largely because of his work. So do book on that if you're interested. That will be free, as this one is. We also work with schools, STEM events, and the next one is in Basingstoke at Team Tech on the 29th of June. So this is just a screenshot from our website. It's the sort of things you can see we get up to. We have a thing called a Reading Geek Night every month, where people just chat and eat and drink, and you get a series of tech talks, and that's always worth going to. So tonight's talk, you will learn how the IP address space is organized into subnets, just taking this from our website. What is an IP address? Network subnetting and the importance of the subnet mask. What is a good default gateway? The presentation is suitable for every professional in the IT industry with a minimum or no knowledge of networking. We have had queries about what version of software will be used. Well, this is a basic introduction, so it won't necessarily be it's not an update on all of the versions that are happening. A few people wanting to be admitted, so I'm just admitting them there. Just going to mute you all for the moment, but do unmute yourselves later on to ask questions. I'm going to hand over to Galatia now. So are you able to share your screen, Galatia?
Yes, of course. Can you hear me?
And I'd leave you to introduce yourself.
Okay. Hello, everyone. My name is Galatia Evangelidou. I'm the network team lead at the University of Stirling. And my fantastic team and I are taking care of the network there. Let me try and share my screen. Okay, hopefully you can see my screen now. I'm going to stop my video just to keep my connection more stable here, because I can see some pop-up notifications came up saying that my connection is not very good.
I can see, I can only see your notes in very small thumbnail, Galatia. I don't know if that's true for everybody else.
I can see the PowerPoint. Sorry, OneNote. That's what I see.
Yeah. Galatia will be presenting in OneNote, not in PowerPoint.
Mhm.
While we're getting that sort of clear, we have agreed before we started that her slides will be available in PDF format afterwards, so we'll send you those.
Mhm. I'd like my presentations to be interactive, so you can use the chat to ask any questions or answer any of my questions. So feel free to pop your messages in there, and I'll keep an eye on it. I'm going to start, sorry, before I start, I'd like to say that this is an introduction to networking. So I'd like to keep things as simple and as not scary as I can. So this is exclusively, this presentation is exclusively for IPv4 addressing, okay? No IPv6 tonight. So let's try to answer this first question. Can you recognize a valid IP address? So let's see. Let's start from this one. Does this look like a valid IP address to you?
Yes,
And
it does.
just use the chat to answer the question. I can see 2 yeses, 3 yeses in there. Right. So you're right. Let's answer the question for now, and let's explain later. Okay. What about this one? Does this look like a valid IP address to you? No. Okay. Let's go to a more tricky one. What about this one? No. Okay. So you say no to this, and yes to this. Okay, what about this one? I can say yes. Yes. Okay. Let me try to confuse you then. What about this one? A no? No. Okay, so you said this is valid and this is not valid. Okay, let's not do the other two, because the question is going to be answered later by you again to see if you got things right on your first try. Let's move on to the next slide, and let's explain some IP address basics. IP stands for Internet Protocol. Okay, an IP address is an Internet Protocol address. An IP address has got 4 octets. Each octet is separated by the next one by a dot. So let's say, for example, an IP address is of the form of something dot a number. Okay, number dot a number dot a number dot a number. Okay, 4 octets. Each octet is equal to 1 byte. So this octet, this is 1 byte. Okay, 1 byte. And this is, again, 1 byte. And another byte, okay, 3rd byte and 4th byte. So in total, 4 bytes. If you remember from the very, very basics in information technology, each byte is how many bits? Do you remember? So 1 byte is, yeah. Not sure if I'm pronouncing your name correctly, Rizwan. So yeah, it's 8. 1 byte is 8 bits. So we've got 4 by 8 bits, which makes 32 bits long. So an IP address is always 32 bits long. Okay. And let me answer the last question here. Why do devices need an IP address? You may know that each device that connects to the network has got a MAC address. and the MAC address is unique for the device. Okay, no other device has got the same MAC address in the world. No. IP addresses. So why don't we just communicate? Why don't these devices communicate with their MAC addresses, and they need an IP address as well? They could communicate with their MAC address, but only in a local level. So they can use their MAC addresses, devices can use their MAC address to communicate with another device, but only in a local network, only in our home network, only in our office. In order for them to communicate with other networks, devices that are connected to other networks, maybe the internet is a different network than our house or our home network or our office. So that's why we need IP addresses to make them, to make the devices communicate with devices to other networks. Let's go to the other slide, private and public IP ranges. I've got here, this column here is private ranges. So these are divided to classes. So we've got class A, class B, and class C. And in total, there are 5 classes, but this class A, class B, and class C are the main classes we use in private networks. And this network can be our home network. It's a private network. Office network, again, it's a private network. Schools, whatever is not publicly connected in the internet is considered a private network. So our home network, let's say, can have a class A IP address, or a class B, or a class C. What helps us choose between classes is basically the range, the capacity they offer. So can you see a class A network offers 128 possible different networks, and each network, can you see, it's got more than 16 million devices. So do we actually have 16 million devices in our home? I wouldn't say so, unless it's a very big home. But that's why our home networks is of this class, class C. And if you go and query your network configuration at home, you're always going to see an IP address of this range here, 192.168.something.something, okay? Because this enables many possible networks, different networks, and each one of them can hold 256 hosts. So it's more than enough, I believe, for an environment at home environment. All the other ranges, so whatever doesn't belong here, can be considered public range. So, for example, a very well-known IP address between network engineers is Google's DNS server, which is this IP address, 8.8.8.8, so the 4 8s. Whenever something happens to the network, or we deploy new configuration in the network, we just try to ping this 4 8s to prove that our devices, our network can see the internet. Okay, so can you see this IP address has nothing to do with these 3 ranges because it's in the internet. As simple as that. Let's move on. This is a funny part of the presentation, and please don't be scared with binary. We're going to do some maths here. I'm going to tell you a story here just to try to explain the binary system, and then I'll tell you what is the relationship between the binary system and networking. And I'm not sure what's your background in IT, but you may know that everything in IT, everything on our computers, on our systems, is binary, is in binary system. And the binary system is called binary because it has only got two binary numbers, two binary digits, 1 and 0. Okay, everything is in 1 and 0. 1 represents presence, let's say, of electricity in the microchips, and 0 represents no electricity in the microchip, so the current. So the computer, let's say, can distinguish between 1 and 0, looking at the presence of current in its circuits. Let me tell you this story. So we've got Alice and Bob here. Alice and Bob are two figures used mainly in examples in cybersecurity concept. So I'm going to borrow these names for my example here. So Alice and Bob are two colleagues working in the lockdown market. So the lockdown market is a shop selling kits, video cameras, microphones, headsets, wireless devices, keyboards, mice to businesses. And you see, we've got some customers here waiting in the queue, and the first customer arrives and he's asked for 210 boxes, 210 sets. So Alice calls the order to Bob, and Bob goes here to the storeroom and carries one box each time. So he carries one box, brings it here to Alice, and then goes back to the storeroom, brings another box, and then so on and so forth, 210 times. That's why you can see him, he's sweaty, he's frustrated. So the first customer, okay, he's happy. Second customer, he's waiting and waiting, so he started feeling not quite happy. The last customer, you can see he's sad. So the two colleagues here need to think of a system to change the way they serve the customers. And they have a meeting and they say, okay, we need to change things here apparently, and let's come up with a solution. So their solution, the solution they come up with is they have decided to use palettes. So they introduce this palette system, and they've got a palette of 128 items. Second palette is 64 items, 32 items, next one 16, 8 boxes, 4 boxes, 2 boxes, and single 1 box. So next time a queue of customer arrives, so let's say, for example, the first one again wants 210 boxes, Bob doesn't carry the boxes one by one each time, but carries the whole palette. So let's analyze this order of 210 boxes, 210 items. Bob gets this number. This is a decimal number, okay, 210. It's in decimal, and uses flags. So 210, he needs a palette of 128 items. So he puts a flag here. Let's see what's left. So if he delivers the palette of 128 items, so this is 2, this is 8, okay. So what's left is 82 more to go. Again, he puts a flag here on the 64 palette, okay. So 64, what's left? It's 18, okay. Apparently, he doesn't need a palette of 32 to deliver the 18 left, but he's going to put a flag here on the 16. Okay, again, he does the math here, and he's left with 2 boxes. So no flags here, no flags here, a flag here, and no flags here. So what he's done, what we've done here, we used this example to understand how the binary system works. If we try to translate this image here to binary, so its flag is 1 and each cross is a 0, and we've got this number, this binary number is basically number 210 in decimal. Okay, and some of you might ask, how did you come up with these numbers here? These numbers are powers of 2. Okay, so here let me use a different color. Starting from the smallest number, so this is 2 to the power of 0. Okay, is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 6, and 2 to the power of 7 is 128 in decimal. Okay, let's do a second example just to make sure that everybody can understand binary. Let's do 15, which is way simple. So Bob wouldn't put a flag here on the 128, no flags here, no flags here, no flags here. So for 15, he's going to put a flag here. Okay, 8. So let me do again the math here. If you subtract 8 from 15, we're left with 7. So again, we need another 4, a flag here. And then if we subtract 4, we're left with 3. So another 2 and 1 to make the 3. So 15 in decimal in binary is, let's do the whole 8 bits here, 4 leading zeros and 4 ones. So number 15 is 4 ones in binary. Okay, I hope that everybody's in a position to understand how it goes now. And now the question is, what is the relationship between binary and networks and IP addresses? As we said before, an IP address is 4 octets, and each octet is 8 bits, okay, 32 bits in total. Here at the bottom, I tried to represent my 4 octets with this palette system. Okay, so each number here in my IP address is a binary number. Okay, supposedly the biggest number, the greatest number each octet can go up to is, if we go, sorry, let me put it in here. If the greatest number is if we put all ones in each bit. Okay, if I put all ones for the whole octet, what number do I get? 255. Okay, if you add all these numbers together in decimal, okay, it's 255. So each one of these octets can go up to a number of 255. Okay, now let's go back to the first page, sorry, here, and let's do the exercise again. Okay, sorry, let's do the exercise again. So now let's answer the question. Can you recognize now which is a valid IP and which is not? So is this a valid IP address? Yes, this is a valid IP address. Is this a valid IP address? Yes, it is. What about this one? It is a valid IP address. I'm very happy because some of you answered answered no the first time, but now you're getting things right. What about this one? Is this valid? No, it's not. It's not. This one? This one is a valid IP address, correct. This one? This is not a valid IP address. Yeah, this octet is correct, but these two octets don't look right because, as we said, each octet needs to go up to 255, and this is again, this octet is correct, but these two octets have got a problem. And last but not least, this one is a valid IP address. That's correct. Nice. So let's move on. Let's move on to subnetting now. And let's read this sentence here. Subnetting is the process of dividing a big network into smaller networks called subnets. But why? The network space is very big, okay? So we always need to preserve IP address space, okay? And also we need to rationalize our network. So as I said previously, it would be kind of a waste to use a Class A IP address with 16 million possible devices in the same network for a home network or for a small office. Okay, we always need to think about how we can support our network in the best way possible. So let me also another very, very important reason. Imagine a big network. There is something in networking, we call it broadcast domain. So the broadcast domain, imagine as a group of devices in the same network, each of them trying to discover other devices to communicate with. So each time a device is connected to the network, the device, let's say, sends this broadcast packet to the whole network, to the whole domain, asking things. For example, a broadcast packet can say, "Oh, who's my default gateway? Okay, who's my router? Who's my switch? Who has got this MAC address? Who has got this IP address?" Imagine a network of 16 million devices, all of them broadcasting these packets, these broadcast communications heard to everybody in the network. This noise, let's say, noise traffic, is going to take over the actual communications there, and we want to avoid this. Okay, we want to keep the network as quiet as possible for actual transmissions to be able to happen. Okay, that's why we need to subnet our network to make smaller groups. Also, another reason is to make it safer. So we are dividing the network between different teams, different groups of computers, different groups of devices, for them to not be able to speak to each other, to communicate to each other. So let's say we want to keep HR traffic separate from IT traffic. Okay, marketing people, marketing staff have no reason to go and see what's going in a research device or computer or server. Okay, that's why we give them different IP addresses. So let's say we've got a group of network engineers, and the network architects say that, okay, we're going to deploy this new, let's say, headquarters network, and you need to configure this IP range 10.0.0.0 up to 10.0.7.255. So the network engineers say, yeah, okay, let's do this. So we've got 1, 2, 3, 4, 5, 6 subnets. Okay, let's go, and we said its network is up to, its octet is up to 255. So let's go here and say, give this marketing group marketing team the 10 range 10.0.0.0 up to 10.0.0.255. This is the greatest number we can give them. So since we exhausted this last octet, now we need to work on this octet. Okay, so this accounting team is going to have the 10.0.1.0. Okay, up to 10.0.1.255. Okay. We haven't exhausted this octet yet. It needs to be, it needs to go to 255 to be exhausted. Okay, so we will continue with this octet. Oh, what happened here? Okay, HR 10.0.2.0 network up to, let me put it here, up to 10.0.2.255. Okay. Next network here, we haven't exhausted, we have exhausted the .2.255 network here. So again, we're staying at this octet. Can you put in the chat what, according to this plan, what our network engineers are going to give this team here? What is the range of the subnet? So it's going to be 10.0. Yes, yeah. 10.0.3.0, that's correct. Up to 10.0.3.255. Okay, I believe I don't have to ask you about these two networks. Okay, you got it right. So 10.0.4.0, 10.0.4.255, and 10. Let me do this one, 10.0.5.0 up to 10.0.5.255. And now the network architects are happy because, can you see? We haven't even touched this range here, which is the greatest we can go to. But we've got a problem here. It's not a problem, but it's something that's not right, because the subnets we keep for future implementations and for future projects, okay, future needs of the organization is 10.0.6.0 and 10.0.7.0. So we have only got two networks to connect future clients, future teams. So what if this HQ building requires Wi-Fi? So let's say we allocate this to Wi-Fi clients, and then something happens. I don't know. They want to expand Okay, and they get another team. That's our last subnet. So now what we've done, we need to expand further the range, or maybe disturb the next range that starts right after this one to a branch network. Okay, so you see that we've done the job for now, but it's not ideal. Okay, because now we need something called subnet mask. This is where subnet mask comes in to help us do things right. Subnet mask. It is the critical component to identify the scope of a network range. So in plain English, the subnet mask tells us how big the range is. Okay, we said here previously, let me return back, we've given all the networks a capacity of 255. Do we actually need 255 for each of these networks? Who knows? But we've given them anyway. So without subnet masks, our network is going to be flat. Same capacity for all the subnets, which is not right. Okay. In binary, what does this mean in binary? In binary, it's a series of consecutive ones, which represent the network part, followed by a series of consecutive zeros, which represent the host part. Let's do some examples here. We've got a network IP address of 10.0.0.0, and we've got a subnet mask of 255.255.255.0. What does this mean? One thing we should remember is the consecutive ones, which is the network, and the consecutive zeros, which is the host. Okay, this 10.0.0.0 network goes along with its subnet mask, which is 255.255.255.255. Sorry, .0. Let's do the ones. So what, if you remember from previously, 255 in binary is 8 ones. So we've got 8 ones here. 1, 2, 3, 4, 5, 6, 7, 8 ones. Okay, dot another 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot no more ones. Okay, because we've got a 0 here. So if you see here, consecutive ones means network. All this range, all these 3 octets is my consecutive ones part, which is my network. Let me use a different color here. Okay, so imagine we've got a barrier here, let's say, okay, to separate my network part from my host part, because this is where my consecutive ones stop, and this is where my zeros start. So this part is my network. This last octet is my host, which means my network is going always to be a 10.0.0.0 network, but my host can be the .1 host. So 10.0.0.1. This is a host of my network. 10.0.0. Let's say 62. This is another host of the same network. Okay, the network we said is this part. So this part stays the same always for this example here. And this part changes because we need to provide IP addresses to the host, to a mobile phone, to a computer, to a printer, to a server, to a tablet, okay, to a switch, to a router, to a firewall. Okay, all of them are going to have a 10.0.0 dot something different here on the last octet. Okay, this is this is what this subnet mask tells me. Okay, and because it's a 0 here, I can use the whole of it. So I can use I can use up to 255 different hosts in this network. Okay, let's go to the other example here. Let me get my blue pen back. Again, I deliberately used the same network here just to show you what difference a subnet mask make. 10.0.0.0 network again, but my subnet mask is a 255, 255, 255, 128. So again, the ones and the zeros. 8 ones here, 1, 2, 3, 4, 5, 6, 7, 8 ones here. Okay, 8 ones here, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 128. What is 128 in binary? Because I need my binary number here to represent 128. Let's go back to the palette. Let's go back here. What is 128 in binary? Can you see? It's a very, very easy number. I'm putting a flag here. Let me grab the red here. Okay, I need to put a flag here and no flags because I got my 128. I don't need other numbers to add up to form my decimal number. So what is 128? 1 and 7 zeros. 1, 2, 3. Okay, let me go back to where we left. Okay, so my 128 is in binary is 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. So my consecutive ones, if you remember here, very, very important. And beyond this dot, so my consecutive ones, the barrier, let's say, the logical barrier needs to be here. Okay, so my consecutive ones, this is my network now, and this is my hosts. So my hosts now haven't got a capacity of 255. My network now is the 10.0.0.0 network apparently, okay? But my hosts are now, let's again, just to help you understand what is my range now. If we have the binary system, so 128, 64, 32, 16, 8, 4, 2, and 1. If I remove, because I used this number here for my network now, okay, so this bit here, this bit, the first bit of 128 has moved to the network part of the subnet mask. So this is my host now, okay. If I forget about this number here, and I add all these numbers, what is my range now? Okay, my range is 127, because if I add these two, I'm getting 255. Okay, I removed the 128 from a total of 255, so I'm left with 127. So my range now, my network has got a capacity of 100 up to 127, okay, devices. So my network is 10.0.0.0, and my last IP address is 10.0.0.0.0. 127. Okay, the 10.0.0.135 IP address is not part of this range. Okay, this IP address would be part of this network here because of the subnet mask, because this subnet mask enables me to use the full capacity of this octet. But this subnet mask tells me to stop here. So if someone could see these two different IP addresses, 10.0.0.135 and 10.0.0.127, might say, yeah, okay, 10.0.0 network, yeah, they belong to the same network. Oh no, because the subnet mask tells me that something else, something different is happening here. Okay, so from a first glance, someone could just be confused, but subnet mask tells always the truth, that these two IP addresses don't belong to the same network. Okay, I hope you could have an idea of how the subnet mask works. Let's go to the next slide. Now, let's do things right. So the factor that we didn't take into account the previous time was the capacity of each network, okay, the requirement. So again, we've got the network architects have given us the same range, but now they have given us also the requirement for each network, the capacity. We've got another term here, Vlsm, which means various length subnet mask. So the previous example, we always went for 255 flat network architecture. Okay, it wasn't various length; it was all 255. Now we're going to split the network, to subnet the network in the most efficient way using this Vlsm aspect. And this always tells us to start from the biggest subnet. Okay, we always start from the biggest, which is 68 in this example here. Let me grab my blue pen. Okay, so let's start from 10.0.0.0. Okay, research, I'm going to put an R here. So our research subnet is going to start from 10.0.0.0 up to what? Because apparently the network architects haven't given us the subnet mask, because subnet mask is our job to figure. Okay, what subnet mask? So what capacity are we going to give to this network? 68. Let's do the binary system again. 128, 64, 32. The more you work with it, the more the more easy it becomes, the easier it becomes for you to remember things. Okay, 32, 16, 8, 4, 2, and 1. 68. Can you see? Because the way that the binary system works, I cannot choose. Okay, I cannot choose 68. So I need to go. Apparently 64 is not enough. So I need to go here. Okay, like it or not, we need to go here. This is the binary system. Okay, 128. Also, let's say even if this was close to the capacity I was looking for, we always plan for the future. Okay, always. So it's always a good idea to go 1 or 2 bits greater than my current capacity, just to future-proof my subnet. Okay, so 128. What did we say before? That the subnet mask tells me the network capacity. So I need a subnet mask to support 128 devices. Okay. What is the subnet mask to support 128 devices? We said we need consecutive ones and consecutive zeros. So if this is going to be my zeros, this is going to be my one. I'm going to land my last one of the consecutive sequence here. Okay, here, because my last one, my landing one, let's say, is going to determine my subnet size. Okay. So 128. So my subnet goes to 10 up to 10.0.0.127, because as we said before, my host part, if I add up all these numbers, it's 127, okay, to make the total of 255. Okay, so my next subnet is, so we've done research, okay. Next in order from biggest to smallest is my IT, if I'm not mistaken. So let's go here, 34. Let me delete this thing here. Okay. Yeah. Okay. 34. Where am I going to land my last one? 32 is too small to support 34, so I need to go to 64. Yes, I need to go to 64. So we've got consecutive ones, so another one here. Okay, consecutive ones and consecutive zeros. So these consecutive ones means I need to add these two numbers together. So 128 plus 64 is 192. Okay, sorry, let me erase this from here. 192 for my network, for my subnet, and all this bit for my hosts. So my network for IT is going to start from the next one, okay, 10.0.0.128 up to, I need to add up all these numbers to get my host number, okay. So this is, I've got 192 here, okay. So what am I left if I use my 255 and I subtract 192? It's sorry, 192 is 2, 3. Okay. Yeah, it's 63. Okay, it's 63, correct. So I've got a capacity of 63 devices in this network. So if I start from 128, I need to add 63 to get my last usable IP address. Okay, so it's my range is going to, so I need to add 63 here. Okay, if I start from here, it's going to be 1. Okay, so my next subnet is 10.0.0.0.128 up to 10.0.0.191. Okay, and we've done IT. Would you like to do the next one, or are you good to continue further? Would you like another one? I'm going to give you this all to PDF, so you're going to work with this on your own time. Okay, another one. Yeah, let's do one more. Okay, let's go. We've done IT. Okay, next in order is marketing, 25. Let me delete this from here. Marketing, M for marketing. we need to continue from where we left. 191, last IP address for the IT subnet. We need to start the marketing subnet from 192. Yeah. Up to what number? They've got 25 devices. This is the requirement. 25, it's here, 32. Okay, we said it's better to future-proof the network, so we should maybe go for 64, but let's do this example to see a different numbers here. Okay, different IP addresses, different subnet mask. Okay, let's say 32. Okay, we decided that 32 is enough to support 25 clients here. I need to land my last one from the consecutive ones here. So these 3 bits are going to be 1, okay, to form the consecutive part of ones. And 3 ones, they leave me with 1, 2, 3, 4, 5 zeros, okay? If we add these numbers together, 128 plus 64 plus 32, we're getting 224. That's correct. Thank you. Okay, so this is my subnet mask, 255.255.255.224. This is my subnet mask. Okay, whatever total I get from my consecutive ones here is my subnet mask. So this is, as we said, this determines the size of the network. What if I'm going to use the first 3 ones for my network? What is my host capacity? I need to add these numbers together. Okay. So I need to add these numbers together, which makes 15, yeah, 31. So 31 is my IP addresses for the machines in the network. If I come here, 192 plus 31, what is the last octet up to? So it's going to be 3, 2, okay? Am I wrong here? 3, sorry, yeah, sorry, no, yeah, 2 to 3, 2 to 3. This is my last usable IP address for this subnet. Okay, so this subnet here has got a subnet mask of 255, 255, 255, 224. Okay, which forces me, let's say, to use this range here. This subnet mask here has got a subnet mask of 255, 255, 255, and as we said before, 192. Okay, and this is 255, 255, 128. Okay, and so on, so forth. So if you see, if we go with this rhythm here, we barely touch the 10.0.1. Can you see? We haven't even reached the .1, the octet here to take it up to 1. Okay, look at what I've done here. Look at my spare range. I've given this offices here, these groups here, IP addresses, and I've saved for the future. Big difference, eh? Yeah, if this looks complicated to you, I'm going to give you the PDF, and also I'm going to give you a very, very helpful resource at the end. Okay. Now, CIDR notation. This is very, very easy. Classless interdomain routing. Basically, it is a different way to represent my subnet mask, to communicate the subnet scope, the size. So a network of 255 this is the subnet mask, okay? 255.255.0. As we said, this is my consecutive ones, okay? And this is my zeros for the host. In CIDR notation, my subnet mask is, I've got 8 ones here, right? 8 ones, and another 8 ones here, 8 ones here, 0 ones here. This is a /24 network. So the /24 is a different way to say that this, my subnet mask is 255.255.255.0. Okay, I'm just saying the number of ones in my subnet mask. So let's say if you ever see this type of notation here, /24, what does this mean? This means my subnet mask has got 24 ones. 24 ones is this subnet mask. Okay. Again, same network, the 10.0 network, 25/25. What is a /25 network? 25 ones for the subnet mask. What is 25 ones? I've got 8 ones, which is 255 here. Okay, another 8 ones, 255, another 8 ones, 255. So these are 24 plus another one here. What is another one here? 1 and 7 zeros. What is 1 and 7 zeros? Is the number 128. So this is my subnet mask. The /25 notation tells me that this is my subnet mask. Okay, it's easier, I believe, and easier to say. Okay, and this is a way that network engineers communicate with each other. We don't say the whole subnet mask. We just say /something network. Default gateway. Default gateway is the IP address of the subnet's router. Let me give you a more realistic example for you, because I don't believe that all of you know what a router is. So if you go to the properties of your network interface of your network card on your PC or your mobile phone, you're going to see 3 fields. There's more fields, but 3 main fields. IP address. So for example, 192.168.3.47, let's say. Okay, subnet mask. Subnet mask. What is your subnet mask? 255.255.255.0. Okay, next field, default gateway. Default gateway. What's a default gateway? Let's see. This is how we represent a router. Okay, this is my router. Okay, and this is how we represent the switch. The router is a device in the network which helps different networks to communicate with each other. Okay, the switch only can hold different networks, but they will never be able to see each other. Okay, the router is the device to enable communications, inter-network communications. So that's why we've got routers at home. If we didn't have routers at home, we wouldn't be able to communicate with the internet, which is a different network than our home network. Okay. So let's say we've got these different networks, the .1 network here, .2 network here. The router has got an interface here to connect this network, and another different interface here to connect the .2 network. If we've got a PC here, very artistic, okay, 10.0.1 network, this one, so let's say the .10 IP address on this PC. and another PC here. This is a 10.2.0.2 network. Okay, let's make the .10 again for this PC. These two PCs, in order to, let's say, send emails to each other, okay, they need their default gateway to be able to route the packets from this network, the .1 network, to the .2 network. The router, this interface needs to be part of this network here. And this interface here needs to be part of this network here. So the router is a device with multiple interfaces, each one in different networks. So this interface here, let's give it an IP address of 10.0.1. Okay, it needs to be part of this network. .1, let's say .1. And this interface here, 10.0.2.1. So this PC here, its network configuration, similar to this one, is going to be IP address 10.0.2.10, subnet mask, let's say it's a /24, okay, 255.255.255.0. Default gateway is this one, because it needs to know where to send the packets to be routed to different networks. So this computer here needs the default gateway IP address to say that, okay, to reach different networks, to reach networks that are not a .2 network, but they are a .1 network, or they are an internet. You need to send all the traffic to this router interface, and this is your router interface. This PC here has got different default gateway because it's a different router interface, and always needs to be part of the same network to be able to see each other. If my default gateway was, let's say, on the .4 network, it's different. Okay, it's impossible my computer here to communicate with a .4 network because it's different networks. So my default gateway needs to be in the same range. So it needs to be necessarily to the same network. Traditionally, we choose the first or the last IP address of the range for our router interfaces, okay, for our default gateways, just to make it easier to remember. It's either the first or the last, so I personally like to make it the first one of the range. That was it. That was it for tonight. That was the material of the presentation. And let me give you these resources here. So we've got, let me share my other screen. Let me see. Okay, let's go here. Can you see a black screen with white letters? No. Yes, okay, cool. So this is my command prompt, okay? This is if you go here and type CMD and click enter, okay, this is the window you are going to end up with. And Windows command line, I'm going to put this in the chat. Apparently, I'm going to return to the presentation after I finish with this. So this is the command. Let's type ipconfig/all and hit enter. Okay, oh, lots and lots of information, but let's go here Can you see wireless LAN adapter, wireless local area network adapter, Wi-Fi. So this is my wireless network card on my laptop. Physical address is the MAC address. So this address here is unique in the entire world. No other device in the world has got this MAC address as my network card. Okay. IPv4 address. Let's go here. This is my laptop's IPv4 address in the Wi-Fi. Okay. 192.168.1.108. This is my subnet mask. What I can see here from my subnet mask, it's a /24, which means 255 clients. Here, the last octet, which means my home network can support up to 255 devices in the same network. If I connect my smart TV, my 5 mobile phones, my 18 laptops, okay, my Alexa, my smart, I don't know, washing machine or whatever, at some point, I need to consider that I've only got a capacity of 255 devices. So, yeah, I don't believe a home network will ever exhaust the capacity, but who knows in the future. And default gateway, can you see? My default gateway is in the same subnet as my laptop. 1.1.1, and my laptop is the .1.108. Okay, let me give you an idea of what Ipv V6 IP address looks like. Can you see? Very, very different. We have 4 octets here, IPv4 address, 4 octets numbers up to 255. Here, IPv6 is not binary. It's hexadecimal. Okay, that's why we've got this strange in the eye combination of letters and numbers. But this is a conversation for another presentation, maybe. It looks scary. It's not. It's not. Okay, it's just different different mathematic system, different numerical system. Another resource I would like to show you, let me put it in the chat. It's this one, and this is what I was talking to you about previously. This is, sorry, I've got it here. So this very, very, very helpful tool is a subnetting tool. Okay, so whenever my colleagues and I want to do the calculations very, very, very quickly, and we work with sizes and subnets that are not the classic, like say very easy /24/25, which we remember very easily in our heads. But let's say, okay, let's do an example here just to show you the what this tool can do for us. So we've got the 10. Let me use a different network, maybe. 192.168.168. Yeah, let's say .10.0 network. Okay. If I'm going to have a subnet mask of /24, okay, calculate. So here, the address, my network, okay. Sorry, this is what I've given. Okay, I've given the 10.0 here and /24. My network IP address is 192.168.10.0/24. Host minimum, so the .1 is my minimum host here. The 254 is the maximum host. Okay, and this network has got capacity of 254. I deliberately didn't tell you all the details. So yeah, if you want to look up what is a broadcast IP address, yeah, Just ask Google and it will tell you. So yeah, the last IP address, the .255, we never use it. We cannot allocate it to a device. Okay, it's 254. Let's say that this is not a /24 network, it's a /25. Let's see what happens. Okay, my subnet mask now, it's not a .0, it's /25 is a 128 subnet mask, which means my network starts from 1 and the host max, can you see, it was 254, it's now 126. And I like this tool because it tells you the binary, how the calculations happen here. If you see the binary system here, the consecutive ones and consecutive zeros, can you see? Subnet mask here, consecutive ones and consecutive zeros. And again, if you go to the binary system 128, 64, 32, 16, 8, etc., and add these numbers together, you're going to get these decimal numbers here. Okay. And also it tells you if it's a private network or a public network. So let me give you a public IP address here. So let's say 8.8.8.8. Let's do the Googles, and this is a /, let's say 28. Can you say get nothing? No private node here. Okay, and /28. You can see it's a very, very small network. Small network, I mean small capacity, because half of my last octet is with the network part, and only these 4 bits are my host capacity. Can you see it's only a 14 network, 14 hosts. Okay. And last resource, let me return to my presentation screen. Last resource is this one, which I believe we have returned to the presentation screen. Okay, I'm not going to open this in a window to show you, but this is for you to study in your free time. Yeah, I wouldn't like to open it just now. All the things we discussed tonight, you can find all of them in this very, very nice website. I wouldn't like to open it because it may have ads and other stuff I wouldn't like to show you just now. Okay, and that's it. That's it. Any questions?
Feel free to unmute yourself if you want to ask a question. We have overrun, but it's been so interesting. I'm sure we don't mind.
I have a question, if that's okay. Yeah, thank you for the presentation, first of all. Yeah, it's quite interesting. But my question is, in terms of the private IP addresses, when you said like 192, that's for private. So when you want to access the internet, does it change to a public IP address? If that makes sense.
Yeah. So all the private networks. Let me go here on the default gateway. Let's say that if we can imagine, let's say that this is our home network. Okay, we've got all of us have got a router in our home. This, let's say, is the demarcation demarcation line of the public and the private. So this is the private. This is the private network, and the router. So let's say this is my ISP, internet service provider. I wouldn't like to say names here. So you already know some names of what companies we go to get our broadband lines. So a cable comes from the wall and connects to my router. This is public. So whatever is from here, from this interface, from this slot that my broadband cable comes to my router, from this point on is public network, okay? And that's why I need the router. I hope this makes sense to you. So whatever is from this demarcation line and in is these three classes of private IP addresses. Whatever is from this interface and out is public.
Okay.
And yes, there is a procedure here going on the router to translate between these two networks. Okay, router is a fantastic device. I just hope that some of you feel more keen on, I don't know, following a networking career or get things more, you would like to dig a bit deeper into your networking skills and knowledge.
Yeah, definitely. I'm planning to take the CompTIA Network Plus or Enable when I get enough knowledge. So yeah, I'm looking to get into networking.
Nice, nice. Any other questions? No. Okay. Thank you so very much for attending the presentation. If you would like to find me on LinkedIn, and if you have ever thought of any other questions, or if you need help or more resources or advice, just feel free to connect with me on LinkedIn and reach out.
Okay, and thank you, Galatia, for a really helpful introduction.